Good morning, everybody. So very warm welcome to my keynote speech on open source in heavy machines, how we work with open source at Bosch Rexroth. My name is Christian Graben, and I'm working with Bosch Rexroth as a business owner for connected off-highway machines. So before we jump into this topic, I would want to give you some brief information about the organization that I'm coming from. And this is Bosch Rexroth, and Bosch Rexroth is a 100% subsidiary of the Bosch company. So Bosch company represents roughly 400,000 associates, makes a yearly turnover of 80 billion euros. I guess most of you know Bosch from the automotive sector as the #1 automotive supplier. And you're right, so automotive segment makes roughly 60% share of sales. Beyond that, there are 3 other business segments, and this is industrial technology, where I'm coming from, and which contains mainly Bosch Rexroth, but also energy and building technology and consumer goods. I guess most of you might also know Bosch from the consumer goods space. For example, Bosch Siemens household appliances with the brands Bosch and Siemens, of course, but also Neff and others. However, there is also the home improvement branch with power tools. You know it from the electric drilling machines or from gardening technology, like lawnmowers. Rexroth itself is representing roughly 8% from the staff perspective, from the employees perspective, with 30,000 total staff, making 6 billion euro total sales and being present in more than 80 countries with sales and service network and manufacturing locations in roughly 20 countries. But what does Rexroth stand for, and what are the products that Rexroth is supplying, and what industry are we talking about? When we talk about Rexroth, or the division or the business unit that I'm coming from, we are supplying products into the off-highway segment or into the segment of mobile machines, as we call it. So mobile machines are those machines that you can see here on the screen. So those are, for example, construction machinery like wheel loaders or excavators on the right, but also material handling machines like cranes or forklift trucks, but also agricultural and forestry machines like tractors, harvesters, and so on. So typically, we supply hydraulic components into those machines, which are then used to propel and propel the machines in themselves, but also actuate the implements like the boom or bucket of this standard excavator. Beyond the hydraulic components, we talk about a large electronics portfolio, and now we're getting a little bit closer to the topic of software, open source. So our portfolio of electronics is called BODAS, which stands for Bosch Rexroth Digital Application Solutions. And there we have 3 pillars. So #1 is electronics and hardware, electronics hardware on the right. So consisting of control units, sensors, HMIs like displays or joysticks. So there's quite some synergy with our automotive colleagues, especially when it comes to sensors or control units. And in addition to that, we're also developing software. In most cases, it's standard software, but we're also doing customized software for our customers. But this standard software is really intended to run on different kinds of machines. Reason is that in our industry, in our segment, we have much smaller fleet than compared to the automotive industry. And we can only leverage on economies of scale if we do standardization. Beyond that, there's our Third pillar, our newest sibling, and this is our IoT and telematics offering, which is called Bodas Connect, and which I'm representing today as the respective business owner, being responsible for the development, but also for the commercial part. Now let's dig into that for some minutes and have a look at how we use open source in these kind of IoT and telematics products. So here, in a nutshell, you can see a high-level architecture or how the data flow from left, the applications, the machines, to right, to the cloud and to the backend. In between, you see the hardware or the things, the big T in IoT. And at the center, there's our connectivity unit, which transmits data out of the machine into the data management backend, where data are enhanced, where data are aggregated and visualized. Below, there's the device management, which is used for managing the electronic units, the electronic connectivity unit, or the electronic control units or sensors. Now let's have a closer look at those two devices, which are clearly driven by software. There's a fundamental difference if you look at those components. And if you look at the top one, this is the electronic control unit, quite similar to the electronic control units that you know and that you see in automotive industry and passenger cars. So typically nowadays, passenger cars, we're talking about tens, if not even hundreds of those control units, which are in most cases powered by microcontroller architecture. So for those microcontroller-based devices, you have a quite specific tool chain. So those microcontroller-based devices, they are highly specified, highly customized. They are very efficient, but of course, they are not that versatile as microprocessor-based devices. This leads to a more proprietary tool chain. And this also leads to the fact that open source modules are not that freely available like in the other spaces. This is completely different when you look at the microprocessor-based devices like the Rexroth connectivity control unit on at the bottom. So here, microprocessor-based means in most cases, there's an operating system running on top of it. In our case, it's a Linux operating system. And of course, with Linux, you already know there's a clear relevance for open source. And there are on top of it, many open source modules available, and different from the other microcontroller-based architecture, you have a large variance of different coding languages, for example. Now let's have a look at the software architecture for our telematics control unit, our Rexroth connectivity unit. And this is what I've brought here. I don't want to dig too deeply into that. I just want to show briefly our layered approach with a Linux operating system at the bottom, then a hardware layer, communication broker, and on top of it, an application layer. For this application layer, we're using containerized modules, and there we're relying on Linux Snap technology developed by Canonical as part of the Ubuntu distribution, Linux distribution. So now let's have a closer look at what kind of open source modules we're using. For example, I already talked about Linux, and we're using Debian as our distro. Then when it comes to the communication broker, this is based on MQTT, and for that, we're using Mosquito. Interfacing to the CAN bus, we're using CAN tools as an open source module, and we're building our web front end and our web interface on Angular. Now, as I already mentioned, for us, it's quite important to collaborate with our customers and to offer our customers the chance to develop their own software, to develop their own modules and to collaborate with other partners, other suppliers, for example. And for that reason, we disclose and distribute, for example, example code as open source on our GitHub. Now, let me summarize why I believe open source is a good idea in our industry and a good idea in our segment. And for that reason, I brought our top 5 reasons to use open source. Number 1, time to market. For us, it's important that we don't want to reinvent the wheel. So take what's already available, use it, and this is one of the reasons why we built upon a Linux operating system, for example. Number 2, proven by heavy use. And you can directly see it by the example that I brought with me on the top right corner, that, for instance, the kernel defect density for the Linux kernel is lower than the industry average. This already shows that for open source, there's a high chance that somebody else has already found the initial bugs. Because it's so heavily used, the quality is typically much higher, and this helps, of course, a lot. Number 3, functionality. So with open source as standard, and as such, in some cases also commodity, we can completely focus on our core competencies and our unique selling points. So why would we want to work and develop something that everybody else considers as a standard and for which nobody wants to pay anything? So this means clearly focusing on the differentiating elements. Number 4, and of course, the issue of cost has to come here. And I don't want to say that using open source means it's not associated to cost, and we don't need to take some money in our hands even if using or when using open source. Of course, there are also maintenance costs, but nevertheless, just by looking at the Linux fictive kernel cost, it's clear it doesn't make sense to develop something like that from scratch. Why would anybody want to do that? And again, here comes the argument of our small fleet and our small quantities. Number 5, and this is about vendor lock-in. So this is a quite important argument for using open source. So you can easily benchmark different technologies, different solutions, and then you can take the superior one. This is important for us. Of course, you need to have the right competency to compare, to distinguish, and then take the right decision. And yes, I know those are already 5, but nevertheless, I brought another one with me, and this I call 5+. And this is about cross-company collaborations. I believe open source is really a perfect means to facilitate this kind of collaboration. Now, having talked a lot about open source and why we using open source, but there's another topic that I want to talk about, and from my perspective is closely linked to the topic of open source, and this is inner source. So collaboration within the Bosch organization, and as I've already shown, with 400,000 employees, of course, collaboration within the organization is already something which is quite important. So let me show you the endeavor that we have taken within the Bosch organization. And this is about so-called BIOS, Bosch internal open source. This was started 2009 as an experiment and as a proof of concept to generate first learnings. In 2013, then, we extended this and we created BIOS as a new development approach. 2016 was then the starting point of an extension and branching. So still BIOS was and is the gold standard, but we realized that by making use of the tool chain of this BIOS approach, this is something which a lot of our developers could benefit from. And this was the starting point of our social coding platform as some kind of tool chain, also for non-BIOS developments. Nowadays, we focus on decentralization, the facilitation. So not only having a central team focusing on our BIOS activities, and further improve our BIOS legal framework around it. In order to give you some idea how we work with BIOS and how this is used within our organization, I brought some statistics. This is about how frequently social coding, be it BIOS or even non-BIOS, is about 13,000 users. And in total, this means 20,000 repositories with 15% share of BIOS projects within these projects, within these social coding projects. And in most cases, it is like that developers or projects start with non-BIOS projects. So they want to get a first idea, they try it out, they try out the social coding platform, and they are using closed projects. But starting from that, they realize that how powerful this BIOS approach is, especially when it comes to collaboration between units, organizational units, business units, when it comes to collaboration across border. And then they start going into the BIOS region. This is also what we did with our developments, with our projects. And we also started as closed project, and then we realized how beneficial it is to use this BIOS approach. In this slide now, I want to show you some network diagrams. And what you can see on the left is basically the network of social coding. So the different colors represent different organizational units. So each color stands for one organizational unit, and the lines represent the collaboration between different units. The closer the units are and the closer the individual organizations are, this means the closer the organizational units are from a business perspective and from an organizational perspective. The more remote they are located here on this frame, the more remote they are also located from a business perspective. On the right now, you can see this green organizational unit, how this collaborates throughout the whole Bosch organization. And you can see it's not only collaborating with very close organizations which are in their direct vicinity, but also collaborating throughout the whole big Bosch family. And with that, I want to close, and I want to say, I think open source software, be it inner source or traditional open source, is a great means and a great facilitator for collaboration and a real booster for innovation and advancement of technology. And this means thank you so much for having me. Thank you so much for the time. And I'm more than happy to answer any of your questions. Please don't hesitate. Thank you so much.